It's pretty much hard to open any news website, flip through any magazine. Everybody is talking about renewable energy right now. And the thing with renewable energy is that globally, on a global scale, it's happening everywhere. There was this article out a couple weeks ago where renewable energy surpassed fossil fuels in the production of electricity in Europe last year. So more power being produced from renewable sources than fossil fuels. And so, of course, we see these kinds of headlines and this information and we go, hey, why aren't we doing that here? Why isn't Alaska doing this? And I think we all kind of know that standard and experience where not everything is a one size fits all, especially for us here in Alaska. And so if anything to think about and remember from today's presentation is that while there are different renewable options that can certainly provide power resources, they are not a one size fix it fit all can produce power for you year round type solution. So we have to look to other solutions and other integrations to make it all work together. So to talk a lot more about that in a more fun way and in better detail, I am going to introduce Josh Kraft. He's our grid modernization manager and essentially our renewable energy expert. And he's going to provide us with an overview of the different renewable energy options as well as access that our member has to different programs. So Josh, if you want to take over, I will swap slides for you.
Okay. Well, first, let me introduce myself, as I'm sure most of you don't know who I am. As Jennifer said, my name is Josh Kraft. I'm born and raised in Fairbanks, Alaska. I was a contractor. I owned my own residential construction business for 10 years. I also was the project manager for Delta Wind Farm and Alaska Environmental Power. We installed the first commercial wind power on the rail belt back in 2008. I moved from there to the Alaska Energy Authority, working for the state, and ran both the wind program and the Emerging Technology Fund program for AEA for 8 years, and before joining MEA in the summer of 2019. So I haven't been with MEA for a terribly long time, but it's been very interesting and lots of great stuff going on. I am currently looking out my window at a nice snowy day in Chugiak, Alaska. So I am a part of the community here. If we want to go to the next slide. I'm going to start talking about membership and renewables, and I'm going to start from our smallest program from a size perspective, but one that you might have heard of. It's our net metering program. And this is a program where members can actually install up to 25 kilowatts of solar or wind at their own home or at their own commercial site. Primarily, you would use that electricity for yourself. If you have unused electricity, you can sell it back to MEA at our avoided costs, which is called the Small Facility Power Purchase Rate. Right now, we have 213 active net metering customers. 185 of those are solar, 20 in wind, and then 8 is a combination of wind and solar. Next slide, please. What does net metering look like? Well, on the left of your screen, you'll see a wind turbine. That could also be a solar generator. The power from that is, whether it's wind or solar, comes out as AC or DC, which means it has to go through some inverter or converter, which is power electronics. Basically cleans up the power so that you can use it or that it can be fed back onto the grid. From the inverter, it's used in your home. And if there's excess electricity that you're generating, it goes through the meter and back onto the grid. And if you are not producing enough electricity for yourself, you can also pull electricity back through that same meter and use it in the home. Now, something that's not diagrammed here is some safety mechanisms that I'll talk more about later, but they would go between the meter and the home. And primarily, they are there to provide safety to MEA crew and MEA personnel, so that if the power was down or if there was an issue with the power line, we could come to the house and then physically disconnect the generation source from the grid. And what that does is it makes it safe for our personnel, because we don't want power to be generated and put onto the grid in a place where they're trying to work. So that way we can make sure that there's no power. Next slide, please. The next size up from there is called a Qualified Facility 1, or QF1. And this is for facilities between 25 kilowatts and 100 kilowatts. It's the same situation where members can generate their own renewable power from solar or wind. In this case, though, all of the electricity from the generation source is sold to MEA at the small facility power purchase rate. And all of the electricity that you would use is purchased from MEA at the standard rate. So it's a little different from the net metering program in that situation. And I'm happy to take questions as we go if that makes it easier, or you can type them into the chat box and I'll try and get to them as we go as well if there are questions. If you can go to the next slide, Jen. Again, the next size up from a QF1 facility, it would be an independent power producer. And this basically is anything over 100 kilowatts. And again, at these sites, members generate their own power from an approved source. The electricity is sold to MEA at a special contract price. So basically the price is negotiable here. Currently, we have several contracts that use the SFPPR rate, but I see a question in the chat box. I'm sorry, I'll get to it in just a second. But electricity is sold to MEA at a special contract price. And then if there's any electricity used on site, you would purchase that electricity at the standard rate. Pictured here is the 1 megawatt solar farm in Willow. And actually, the Willow, Alaska project started out as a qualified facility at 100 kilowatts under a power purchase agreement, and then added 900 kilowatts more just this past year or the year before. So I have a question. So can any homeowner do this? How would someone go about doing that? And I'm assuming that you're asking about the net metering program. And the answer is yes, any homeowner can do this. And you can go about it in a number of different ways. You can do the work yourself if you are qualified or if you have knowledge of doing it. There are contractors available in Eagle River, in Anchorage, and in the Matsu, excuse me. And you can hire the contractor. A lot of them will do site visits and draw up plans for you at no cost. And there's even, in some instances, financing available through those contractors to do these projects. Something I didn't mention, I'll talk more about later possibly, is the potential for an investment tax credit. So if you install a solar or wind project at your home, you can get up to, I think, 22% of the investment back through a tax credit right now. That's if somebody wants to ask an anonymous question, please private message Brittany. Can you, I think we'll slide to the next, go to the next slide here. I do want to make some technical notes on renewables. This picture is a picture of wind data. So basically this shows you how wind changes on a 10-minute time scale over an entire year at one location. So you can see it moves around quite a lot, not only minute to minute or day to day, but also as the seasons go by. And you'll notice that in the middle of the summer, you have less wind in these instances. And that's actually exactly opposite of solar. And I'll talk more about that in a second. But I did talk briefly about the safety requirements. But for all of these different renewable installations, there's going to be different levels of safety requirements. As you might imagine, 5 kilowatts of solar is going to have a different requirement than 5 megawatts of solar. And for the home, that typically means that we want to make sure that we have sufficient breakers installed and that we have a visible disconnect. And that just means that it's going to have a box on the side of the house with a handle that MEA personnel can come and open. to make sure that the power is off. Variability, I was just talking about how the wind moves around. The same thing can be said for solar. It moves around quite a bit. And obviously in the summer in Alaska, we get a lot more solar than we do in the middle of winter. And that's exactly opposite for wind in most parts of Alaska. We get a lot more wind in winter and a lot less in the summer. And this leads to something that's called capacity factor. So when I say that you can install, up to 25 kilowatts worth of solar at your home, you're actually on average only going to get 2.5 kilowatts of solar production on a day-by-day basis. And that's because in Alaska, we have we have cloudy days, we have the tilt of the earth, there's a lot of different factors, but basically the solar irradiance in Alaska results in about 10% capacity factor. For wind in Alaska, that can range anywhere from 10% up to 40, 50%, depending on how much wind you have at an individual site. Wind, I would say, is much more specific to an individual site than solar is. Typically, solar is about the same throughout Alaska, and it's right around that 10% capacity factor. I believe the Willow Farm when we had the very warm summer 2 summers ago, saw a 15% capacity factor because there was so much sunlight. I would be happy at this point to take any questions about the variability or capacity factor, because I know it's kind of a technical issue. If somebody wants to do that verbally or type something in, I'm happy to take that. I'm not seeing anything right away, so I will move on to what's it cost. And
sorry, Josh, this is Brittany Olson. I did have a question come in, but you just started talking about cost, so I'll wait till the end because it might be answered by then.
Got it. Okay. Well, I'll start talking about then. I'm going to give you a very engineering question or answer to that, since I'm an engineer, and the answer is it depends. However, I can give you a range. For some very, for a large solar installation, that I think the Willow Solar Farm saw installation costs of about $1.90 per watt, or $1,900 a kilowatt. If you go into a household installation, you're probably looking at a minimum of $2.50 to $2.75 a watt. And I've seen as high as $4 to $5 per watt. What does that mean for our typical installation is about 7 kilowatts in MEA. So that's about, we're going to call it around $21,000 for a 7 kilowatt system installed. Again, there are some incentives available. There are federal tax credits, and they are reducing every year right now. I do not know if that will change with the administration change, but the incentive was a 30% investment tax credit a couple years ago. It dropped to 26% last year, and it's 22% this year. And I believe it drops down to 15% after this year. So the incentives are dropping away. That doesn't mean that they're going to go away, and there could be changes coming. And I've already talked about wind versus, I didn't talk about costs for wind here. Small residential scale wind or even small commercial is hard to make work. And that's because for wind, bigger is better. Solar is very nice because it's so, what is the payback period? I have heard as little as 3 to 4 years if you include the tax credits, and as much as 7 to 12 years if you if it's a very expensive install that maybe you didn't get much in tax credits. The actual lifetime of solar panels is around 20 to 25 years. However, they can last much longer than that. There is some reduction in production as you go along. I think I answered. Brittany, did I answer most of the cost question? Or
the only other thing I believe was added, I have a couple of them, but is the 10% average capacity for solar enough to run a house on a daily basis?
that answer depends on whether it was a cloudy day. So on average, 2.5, if you installed a full 25 kilowatt system, let me take one more step back. A household on average uses 1 kilowatt, basically a kilowatt hour every hour. So if you have a 10 kilowatt solar system, you will on average generate enough power to run your household. Now, that doesn't mean that you're always going to be able to run your household, because one, there's no sun at night. Two, cloudy days, you're not going to get much production, or rainy days. And so it's highly dependent on what the cloud cover is and what time of day it is. But you could potentially combine some of these technologies with batteries. Again, you start increasing the cost of your project. So a lot of this depends on how much the homeowner or the commercial establishment wants to invest in their own infrastructure in order to have generated power. Did I cover all of the cost questions now? Okay. I think I was starting to talk a little bit about wind costs. So bigger is better when it comes to wind. There are 2 kilowatt machines available. There's a 10 kilowatt machine that is available. The 2 kilowatt all in is about $25,000. So it's a fairly expensive process. If you have a lot of experience in construction or electric devices, you may be able to do more of that work yourself and lower that price. A 10 kilowatt machine is probably more on the order of $50,000 to $70,000. So again, you see a significant price per kilowatt drop by the larger you go. Once you get up into the megawatt scale or the multi-megawatt scale, the prices start coming down significantly. However, at that point, you would definitely be an independent power producer. So I'm going to stop right there and take a breath and see if there are more questions that have popped up, or if anybody has, if I didn't answer any of the questions enough. Brittany, anything popping in on your end?
There is not, Josh.
Okay. Well, let's slide on. There are other types of member-owned generation. Backup or standby power. In these situations, we're talking about hospitals, or we're talking about a tourist location that can't go without power. You might have a backup diesel generator or some kind of generator at your house for if the power goes out. And again, there's going to be special interconnection requirements and safety requirements that this generation cannot be in operation while the grid is up and running. So there's going to be an automatic switch or a manual switch that you would have to flip in order for that generation to actually operate your house. Something newer that is out there is called combined heat and power, or CHP. And you've got two pictures here. On the left is a Yanmar unit, and on the right is a capstone unit. And what combined heat and power is just that, is that it's a unit that generates not only heat, but electricity at the same time. And these can be useful in larger, in some commercial settings. It's harder to make work at a residential level. But the reason I have two, although they look almost identical here, the Yanmar unit is actually just like a diesel generator. It's a reciprocating machine. It runs on diesel or natural gas, I think propane as well. The capstone turbine, the capstone unit is actually called a micro turbine, and you can think of it much like a jet engine. And it will run on also natural gas, diesel, and propane as well. However, the difference between the two machines is, for capstone, you're only going to get about 13% efficient on electricity. So you're going to, for every BTU you burn, you're going to get 13% of that in electricity, but you're going to get about 87% of that, or I'm sorry, 77% of that in heat. So you have a 90% efficient resource here. The Yanmar unit's about a 70 to 80% efficient generator. but you're going to get 35% efficiency on electricity and 35% on heat. So depending on what your loads are, one of these units might make sense for you. The issue that we run into is that they are burning fossil fuels, which are not renewable and therefore not eligible under the MEA QF1 or the net metering program. So you would basically be generating your own electricity. Anything you generated that went on the grid you wouldn't get credit for. However, you can still be hooked to the grid. We just have special safety requirements that are in place to make sure that it can't hurt our personnel once again. I see a question about how MEA feels about nuclear power. I don't know that we have an official stance, but I do know that there is quite a lot of folks in Alaska looking at what are called, it's small nuclear basically, on the order of more like 30 megawatts a piece. You still have the issue of radioactive material, but nuclear power has been safely used in a lot of places for a long time. So it's something that we are listening to, but I don't know that we have any movement towards nuclear power. I hope that answers the question well enough. I don't know that we have an actual stance on that. Next slide, please. I'm going to change gears on you here a little bit, unless there are any final questions on renewables or member-owned generation, and talk about another hot topic item, and that's electric vehicles. And I like to start off talking with electric vehicles by talking about, first off, showing you what an internal combustion engine or ICE vehicle looks like, and then start talking about the various types of electric vehicles that are out there. So an internal combustion engine, you have, basically you're burning gasoline or diesel. You're turning that chemical energy into mechanical energy through burning. You have quite a bit of waste heat, but that mechanical motion of the engine is then transferred through the transmission to the wheels. So you have, again, a lot of mechanical losses there, and then you have motion. An electric vehicle works in a different fashion in that the onboard energy is stored in a battery, and it's stored as electricity and used as electricity. So there's some inherent efficiencies that you gain there. What's pictured in this that diagram on the right is what's called a hybrid electric vehicle, or HEV. And a hybrid electric vehicle has both an internal combustion engine and battery. However, HEV does not charge from the grid. It only charges from the internal combustion engine. So you get some additional efficiencies out of this setup. There are some models out there that are fairly well liked, like the Toyota Highlander hybrid. They're getting about, I think, 35 miles to the gallon by being a hybrid electric vehicle. The issue with hybrid electric vehicles, you're talking, you have an engineer presenting, when you have two different engines, there's just two different ways for things to go wrong in a lot of engineers' opinions. So you want to be careful with some of these. Now, I'm not saying that they don't work and they're not reliable. It's just looking forward, I am looking towards electric vehicles. If we want to go to the next slide, we have the next step is called a plug-in hybrid electric vehicle. And in this case, it has a slightly larger battery than the hybrid, but it still has an internal combustion engine and a battery. The battery can be charged via the grid, and you see on the front left side of this, you have a charge point. And on the back left side, you see where the fuel tank is connected. So again, this one, the plug-in hybrid typically can run for about 30 to 50 miles on the electric engine alone. And it gets a large boost in efficiency as well, just like the HEVs. The electric versions, the electric engines in a plug-in hybrid are meant to operate like in city settings. where you're stop and go traffic, so that the engine is not running and idling during those situations. So you would use the engine on the highway, and then once you hit the city situations where you would be stop and go, you'd switch over to the electric engine and not have those inefficiencies. Then we take one more step and we go to an electric vehicle, which is sometimes called a plug-in electric vehicle, a battery electric vehicle, or just electric vehicle. So I am sorry for all the acronyms, but that's just the world we live in. In this case, we have done away completely with the internal combustion engine. There's a very large battery pack. There's a charge point, a charge port. And in the case of an electric vehicle, the number of moving parts is reduced drastically. So for instance, a internal combustion engine transmission or drivetrain has about 2,000 moving parts. The electric vehicle drivetrain has 20. So there is a significant reduction in moving parts and maintenance issues on an electric vehicle. And I can already hear the question, what about maintenance on the battery? The batteries are now being warranted for upwards or more than 100,000 miles in some cases. They have 10 and 12-year lifetimes. The rated capacity of those batteries is expected to only drop by about 10% over that time period. And the next question I'm sure I'll get asked is, what about fire hazards? There is a fire hazard with lithium-ion batteries, but that's usually from poor manufacturing, from damage to the batteries, or a failure in the software that controls them. And the data thus far supports that electric vehicles actually are a lower fire hazard than internal combustion engine vehicles. So I do know that those are questions that I have received from other people, so maybe I've cut them off at the pass here. I would be happy to answer any other questions on the different types of electric vehicles. I'm going to talk more about charging here in a second, but Brittany, I can pause if there's a question that has come in.
There is not at this time, nope.
Okay, so next slide. We're going to talk about how do we charge these electric vehicles. There are 3 different levels and 4 different types of chargers. And you'll see there's only 3 here because we don't talk a lot about the 4th one. A level 1 charger is going to plug in directly to your typical everyday household outlet. So the outlet that you use to plug your vehicle in at night right now to keep your battery warm and your oil pan warm, that would serve just fine for a level 1 charger. It's about 12 to 20 amps. You're going to get about 3 to 5 miles of range per hour. So for 100 miles, you're talking 10 or 12 hours worth of charge to get 100 miles worth of range. In a level 2 charger, you're going to need a 240 volt plug, which is around 30 to 60 amps, depending on the charger. I know it says 12 to 80 here. I'm kind of talking about the newer brands that are out. These are kind of wide range standards that are available. The chargers themselves run between 2.5 kilowatts, and the newest Tesla chargers are 12 kilowatts. So again, we talk about how much power your house uses, about 1 to 2 kilowatts on average, and a level 2 charger could be using 12 kilowatts worth of power. Now, to completely charge your vehicle, you may need to use that for about 4 hours in order to completely charge your vehicle. Then we step up to what's called a level 3. This is where we say there's an AC version and there's a DC version. Most of the level 3 chargers out there are DC fast chargers. And that basically, it means it converts the electricity to DC you see the box here beside the car in the diagram. It converts that AC power from the grid to DC, and then in that way it's able to shove the power into the battery as quickly as possible because the battery takes DC power. These chargers are somewhere between 50 kilowatts and 250 kilowatts apiece. They are typically grouped at charging stations in numbers of 4 or 8 or greater. I actually heard about a location in Las Vegas where they installed 32 250 kilowatt Tesla superchargers at one location. That is a lot of power if all of those are being used at one time. The charge time in this instance is somewhere around 20 to 30 minutes for you to jump from about 20% to 25% to about an 80% state of charge. An interesting note on EV batteries is they are lithium-ion batteries, much like you have in your phone. And if most people have used their phone, they know that when they first charge, if the battery is completely dead, it takes forever to get up to that 20-25% range. And then the same thing to get from 80 to about 100%. It's really takes a while. But once it hits that 25%, it'll be at like 75% really quickly. Well, the same thing happens with an EV charger, and that's due to the lithium ion technology chemistry. And so it lends itself well to fast charging in that middle range there. Any questions on charging? I am blowing through a lot of this information. There's just a lot of stuff here. So I am sorry if I'm talking quickly. I'm happy to answer questions, or if there's something that I didn't cover, I'm happy to do it.
Josh, I just wrote one in the chat for you.
Okay. Are there any DC
and then I
fast
actually have more I'll read after that.
Okay. There is a DC fast charging station at the Chevrolet of Wasilla, and that is actually a small 25 kilowatt unit. They use this. It's not necessarily meant for public use. I think they allow people to use it, but it's mostly to be able to quick charge. They have both the Chevy Bolt and the Chevy Volt. One of those is plug-in hybrid and one is an electric vehicle, and I cannot remember which is which ever for some reason. But they sell those at their store, and so they wanted to be able to very quickly charge those when somebody came in. In the Chugiak Eagle River area, that is the only DC fast charging station on the rail belt right now that I am aware of. I think Audi in Anchorage may have a private one that they use for their Audi e-tron, but however, is there any in the works that is known? I can tell you that I am working on a number of different charging locations, and we are trying to help. We're working with host sites and equipment manufacturers, and right now trying to identify funding sources for these projects. What I didn't talk about was cost on these, and I'll run through those real quick. Level 1 chargers, they don't really cost anything. They typically, a vehicle will come with a level 1 charger, and you can plug them directly into any household socket. A level 2 charger, you may have in your garage a 30 amp circuit that's already set aside. Maybe somebody's got a welder that they can repurpose that socket. But in most cases, you will have to run a 30 amp or 50 amp circuit to wherever you're going to charge. And with the equipment, that can run you in the neighborhood of $1,000 to $3,000. The equipment themselves, I think, it depends on what versions you buy. They could be a couple $100 and could run up to $1,000 or $1,500. Now, level 3 chargers, we're talking on the order of $50,000 to $150,000 for a site. And that is because you may need new transformers, you may need additional line run, you're going to have to clear pavement out of the way in order to run some electrical wire underground. You have to install the equipment. So there are a number of things that are there inherent in level 3 chargers. So I think I answered the one in the chat box. Brittany, you said you had a couple you wanted to read off.
I'm such a visual person. I actually just put it in the chat so that you could read it, okay, and others can read it as you, because it's kind of long.
Okay. So some people mistakenly believe that using electric vehicles allows them to separate from using fossil fuels. In Alaska, a large percentage of the electricity we use generated from fossil fuels. Has there been a comparison done in Alaska about percentage decrease in fossil fuel usage when choosing electric over internal combustion vehicles? The answer is yes, I'm looking at that. I can give you some general answers right now from a worldwide perspective, and I can talk even about just cradle to grave for both internal combustion engines and electric vehicles. Electric vehicles over their lifetime are going to use less than 50% of the global emissions or greenhouse gas emissions than an internal combustion engine. And a lot of that comes from the production of lithium ion batteries as compared to the production of internal combustion engine. But the overall manufacturing process of an EV is basically the same as a internal combustion engine. And that number actually will come down as China is restricting more and more emissions. Right now, they do not have the same level of restrictions on emissions that, say, the United States and Europe have. So those numbers are skewed because China is involved in those numbers. You are absolutely correct. The question is absolutely correct that you're not going to separate yourself completely from fossil fuels in this way. However, EVs are much more efficient than internal combustion engines. For the reasons I noted earlier, there's less moving parts, there's less energy conversion from the chemical energy in diesel or gasoline to mechanical, and then another mechanical conversion when you go from the reciprocating engine to the spinning wheels. So there's much less energy losses in an electric vehicle than there are internal combustion engines. That being said, the amount of fossil fuels that a electric vehicle will use is directly tied to how many fossil fuels the utility uses. So as renewables grow in generation assets, there will be less and less fossil fuel used to power electric vehicles. So great points, and there are definitely some issues there. I think that overall, though, electric vehicles are still cleaner than internal combustion engines. And I haven't even talked about cost here, but our actual cost of EV, but the cost to operate and maintain an EV per mile is about 7 cents per mile versus an internal combustion engine is about 12 cents per mile. And that's at current electrical and gasoline prices. So depending on what happens with electrical prices and gasoline prices, that could go up or down. I will say that right now, most electric vehicles cost significantly more than a regular vehicle. However, price parity for internal combustion engines and EVs are expected by 2025. So in the next 3 to 4 years, it'll cost you the same to buy an electric vehicle than it will to buy an internal combustion engine. Are there other questions? And again, I know I'm speaking very quickly and I apologize. Okay, I'm not seeing any, and I know I'm getting towards the end, so I'm going to start running through what we call the electric vehicle myths. One is that you can't drive long distances. This may have been true for early models that had less than 100 miles of range. The newer electric vehicle models have ranges in excess of 400 miles. Now, does that mean you could drive all the way to Fairbanks on a single tank of EV battery? Maybe. I wouldn't want to try and do it in the middle of winter. However, when was the last time any of you tried to drive to Fairbanks? I've done it recently, but that's because I have a lot of family in Fairbanks. So for your everyday driving, there is plenty of range in all of the newer electric vehicles. Let's go to the next slide. They're expensive. A lot of them are expensive. That's because the vehicle manufacturers typically put their newer stuff into their luxury sedans and luxury vehicles so that they can offset the cost of production, of bringing those projects up to date. So they do go in the more expensive vehicles. I will say there are vehicles out there right now, the Tesla Model 3 or the Chevy Bolt, that run you about $25,000 to $35,000, especially after you take tax credits into account. And there are tax credits up to $7,500 for specific models. I would encourage you to go to fueleconomy.gov. There is an extensive list of electric vehicles and tax credit availability at that site. Next slide, please. There are only few electric vehicle makes and models. The type of vehicle is fairly limited. You're going to see a lot of subcompact cars through mid-size SUVs and sedans. However, there are a lot of different manufacturers making them, and there are no fewer than 4 trucks set for release this year or next year. That's the GMC Hummer, the Ford, the Tesla Cybertruck, and the Rivian that I know of are all coming out either this year or next year. Next slide, please. I talked a little bit about this earlier, that the batteries don't last very long and they could be expensive to replace. Again, you know, the degradation after 160,000 miles was only 10% for Tesla batteries. That's pretty impressive. And you have to kind of remember that the lithium-ion batteries, though we think we've heard about them for a long time, they really only reached, they've only been around for 10 or 15 years. And that's really not a long time in a manufacturing world. Since 2012, battery costs have dropped 50%, and they're expected to continue dropping for a number of years yet. So they're coming down in price. The manufacturing processes are getting better and better, and so their reliability and their costs, the reliability is going up and cost is going down, which we expect to see in a emerging market. Next slide, please. So I'm going to talk really quick about these different studies that MEA is doing. The variable resource regulation study, I'm reusing this picture because it paints a pretty good picture of why do we need to understand how or what we can regulate. Well, wind and solar move up and down a lot, and we have to, as a utility, we have to provide reliability to our members. Excuse me. And so with the moving and up and down in generation of wind and solar, we have to have enough generation assets online to meet when those drop off. So as wind comes up, we have to drop off our generation, and as wind drops down, we have to ramp it back up. And so there's an amount of ramp rate that we have to adjust for, and there's also just how much can we keep online. So if all of that wind came offline, that entire plant dropped off, can we cover that coming off? So we are doing quite a bit of work in, yes, I'm happy to provide my contact information. Sorry, Brittany. So we're doing quite a bit of work looking at how much renewables we can actually integrate into our system as is. And we're also looking at what can we add to our system that would allow that to grow if we so wanted to. Microgrid pilot project, and the first question I'm going to get from people is, what the heck is a microgrid? Well, a microgrid is basically any subset of a larger grid that can be isolated. So you really, all of the rail belt is a microgrid from the perspective of the lower 48. So because all of the rail belt is isolated within that, you could say that MEA's system is a microgrid because we could isolate from the northern production and the southern production and be just fine. And you could even go smaller to individual feeders and call those microgrids. So what is a microgrid? It's a lot of different things. But what they really do make up is, and I don't have control here, so I can't hover the mouse, but from the utility grid, you're going to have these supervisory controls. And on the other side of that, you're going to have generation resources, you're going to have load resources, you're going to have commercial, residential, and the generation is going to go to the supervisory control, which is now cut off from the grid, and it's going to continue providing power to this microgrid. So if the grid went down on a certain section, say, I'm only going to use this as an example, it's not meant as anything else, but if say the line to Talkeetna was broken, somehow there was a tree on the line, and we had a microgrid set up in Talkeetna, we could keep Talkeetna with power in this situation. If we had a renewable or other generation resource down there, we had supervisory controls, we could potentially keep that in operation. Now, there are a lot of issues. There's a lot of concern about microgrids from you're basically decentralizing your generation, you're decentralizing a lot of controls. And how does that work, especially with the fairly limited level of communications we have between sites? We do not in Alaska have fiber ran everywhere, like the lower 48 might have. So communications is a big issue, and there's some other concerns, but we are looking at microgrids as potential solutions to some resiliency and reliability issues that we do have, especially at the ends of our lines. Okay, I think that's my last slide. Thank you all for listening to me for talk so very quickly. I am always happy to answer questions. I am happy. Brittany, did you want me to type my contact information in or just provide it to you and you can send it to people?
If you don't mind, it would be great to put it on the chat. That way, when we do have that recording available, people can go on the chat and see that.
It's josh.craft@MEA.coop. I would say if you want to send me an email and then we can send me your question, I'm happy to look at it. We can always have a phone conversation after that. Probably the easiest way to do it. And Jennifer, did I cover everything? I know I talked very quickly and we are at the end of our allotted time here.
Yeah, I think you covered a lot of good information. In terms of, I think there was the one question about the level 3 chargers and where they were available. I know down at like, there are some businesses, but I believe they're only the level 2 chargers. But for instance, at the Alaska Resort, they invested in some level 2 charging stations. I believe there's one in the downtown Anchorage, one of the parking garages there. So there are some level 2s, those they're not the level 3 fast charge those. So those are kind of more ideally met in spaces where you're going to park your vehicle for a good amount of time or potentially overnight or during the day while you're at work. So just keep that in mind. And then we do talk with our members about that have purchased electric vehicles and made that switch over and kind of ask them a bunch of questions about that. And we have a video series on our Facebook page that covers those interviews with our members who have gone electric. And they kind of they provide individually like what their cost analysis were for doing that and things like that. So there are some, if you kind of like want to hear some feedback or reviews from other folks who have gone this route and learn about what their experiences have been like, we have that on our Facebook page and our videos section as well. So yeah, it's just I think it's just something that we're going to see more and more trending and becoming more common, especially as the costs come down. I know globally, it used to be primarily wind, and now we're seeing solar match that, and solar is projected to exceed that in the next year or so. So I think we'll continue to see costs come down for these things as they have shown in the past few years, especially. And likely more member interest, if not member adoption in the future. So these are things MEA is paying attention to and making sure that we're able to meet all of our member needs when it comes to power and being innovative in what we can offer our members. So
Jennifer, if I could just add maybe a couple things real quick. A life hack for people if you do own an EV is RV stations have 30 amp and 50 amp plugs. And you can go plug into them for a nominal fee and they will let you charge your electric vehicle. So there are RV stations scattered throughout the state that you can go plug in and use as a level 2 charger. The level 2 charging stations that are available, I think there's a lot of apps out there for this, but I believe ChargePoint you can go to the Play Store or the Google Store and just type in EV charging stations and you can find a different app and they'll show you where all of the different level 2 charging stations are in the state of Alaska or elsewhere. It's pretty interesting when you look at the lower 48, they're all over the place. And just a final note on the renewables is that wind actually was the cheapest new power source in the United States last year.